right. Well, welcome to the August edition of the Utah Data Engineering Meetup. So we got Apache Kylin as a topic tonight. Don Lee is coming through all the way from Shanghai to tell us all about Apache Kylin. So that's pretty cool. I think this is the first time we've had an international guest presenting from across the world. So so welcome, Don. So we usually start off by who's hiring and who's looking. If there's anybody who's hiring, do you want to give a quick shout out to the group about any positions you got open? Anyone?
So this is Devin with Overstock. I'll just say that Overstock is always looking for people. So if you're interested in working with us or are familiar with some of the things we're doing or want to learn more, please feel free to reach out to me and I can get you connected.
Cool. Yeah, Overstock's seen a lot of growth lately. So you guys are doing great. And it's a great team. Devin's somebody I've known for a bit now. And yeah, if you work with his team, that'd be awesome. So you're doing a lot of cool stuff there at Overstock. Anyone else hiring? Yeah, of course. Anyone else?
Recursion's hiring.
Cool. Do you want to explain a bit about what Recursion's hiring for?
So Recursion is a drug discovery company primarily. We're building the math of human biology through data science and machine learning. And we actually have a bunch of jobs open. We have data scientist, senior data scientist with more of a bioinformatics bent. We have a data scientist role that would also be more oriented to drug discovery. And then we have something called a data science engineer position, which is sort of sitting partway between data science and data engineering. Cool. It's a new role for us. I'd suggest just looking at the website and the job description. We also have a bunch of science roles open. We've got biology and chemistry roles open and high throughput lab automation engineering. So awesome. If you know anyone with those backgrounds, we're hiring. That's
cool. Yeah, Recursion's like one of the companies I really look up to in the Valley. Like it's just a really smart group of people doing like just amazing cutting edge stuff with data and AI. So check them out. Anyone else hiring? No? Okay. Cool. Anyone looking for work? Going once, going twice. Okay, cool. If you are, and you don't want to say so in the meetup, you know, we have a Slack group. You can go to the looking for work channel and post there, or you know, feel free to message people, you know, in chat or elsewhere if you know them. So it's a supportive group. We're all looking out for each other. So upcoming events, Utah Java Users Group has actually a really cool functional programming meetup Thursday, which is tomorrow. So check that out. They'll be going over functional programming in Java, Kotlin, and Groovy, I believe. And next Friday, Data Nerd Herd, we're doing a chat on why do most data projects fail. This will be a good discussion with fellow data professionals. So if you're interested in that, hit me up and I'll get you instructions on how to register for that. Salt Lake City Python is doing a talk on GPT-3, which is the latest rage in AI and NLP. So we have somebody demoing that, and that'll be pretty fun. We played with that last week, and I think what was supposed to be a half-hour demo turned into about an hour and a half. Just it was a lot of fun. So the next UDEM, it's the topic CBD, but we're scheduled for Wednesday, September 16th. And then the Go West conference is Friday, October 2nd. So that's, if you're into Go, go check that out, no pun intended. So if you're interested in giving a talk, post it on meetup.com or message an organizer. That would be me or Devin. And we'll get you squared away on that. We also have a Slack group. Again, message an organizer, Devin or I, or here's my email, and I can can add you to that group. So this is a virtual meetup, so the ground rules, I'm pretty sure you're all aware by now because you're all doing a really good job at this. Stay muted unless you want to talk. Q&A, I think what we'll do on this one is write your questions in the chat, and then we'll save them for the end, and then Don will answer the questions. So, and if you don't need video, turn it off. And then with that, I'm going to turn it over to Don. So let it get set up here, and we'll get started.
Okay, let me share my screen.
Okay.
1 minute. Okay, so could you see my screen?
Yeah, we see the slide.
Yes.
Okay. Let's start. Hello, everyone. Welcome to today's meetup. This is Dong Li from Kyligence. And today my topic is Apache Kylin to simplify the machine learning on big data. And firstly, let me introduce about myself briefly. My name is Dong Li, and I'm the head of product and innovation at Kyligence, and also the Apache Kylin committer and the PMC member. And I also worked for eBay and Microsoft before I joined Kyligence. Okay, and here is today's agenda. First, I will introduce about Apache Kylin, and then talk about how to simplify the machine learning scenario of big data with Apache Kylin. And then we'll follow up with a demo video to tell a whole story to how to run that. And finally, we will have several minutes for Q&As. Okay, here we go. The first part is let's just go into the Apache Kylin. Just like you have already know about Hadoop, Spark, and Flink, and so on. There are a lot of softwares in the Apache Software Foundation, and especially for the big data ecosystem, there are a lot of technologies or the open source software in Apache. And the Kylin is also a very important component on big data ecosystem in Apache Foundation. Apache Kylin is an open source distributed analytical data warehouse for big data. And it was designed to provide the OLAP capability in the big data area. It can be used to bring the multi-dimensional cube and the precomputation technology on the Hadoop and Spark, and be able to help the users to achieve near constant query speed, or some seconds or sub-second level query speed, regardless of the growing data volume, and reducing the query latency from the minutes with the traditional way to sub-second Kylin. So Kylin can bring the online analytics back to the big data, right? And now let's start from this architecture. Usually we build the big data form on or the data lake on Hadoop or Spark, and even on cloud. We have several cloud data warehouse technology here at this moment. Yeah, but there is always some gap between the data layer and the business layer, and Kylin is the choice to fill the gap. It can be used to provide the data mart layer to connect the data and the business. In Kylin, users can sync the table structure from Hive or other database, and then build the OLAP cube to serve BI analysis scenarios and other data applications. the most important concept of Kylin is a cube, or you can say that maybe a data model in OLAP domain, which defines the dimensions that measures and finally will present as a semantic layer to the applications. And also, Kylin will pre-calculate the aggregations, the aggregation results in each scenario to speed up the query performance. So as a result, usually the query performance can be less than 1 second on the PB scale data set. Yeah, and Kylin supports the standard SQL interface, which should be the most welcomed data service API for developers and analysts, I think. Yeah. And another very key advantage of Kylin is high concurrency. Thousands of concurrent users can be supported with Kylin, with several Kylin servers that will not very large numbers of servers that can be used to support the high concurrency, right? And that is based on the technology of the pre-calculation. I will talk about the pre-calculation later to describe more. Okay, and also in the latest version of Kylin, it can also analyze the batch data and the streaming data together, which means if the data is ingested in the form of a real-time stream, also parallelized with SQL in Kylin. Yeah. So this is the basic ideas of Kylin, and till now we have seen more than 1,000 users around the world, such as eBay, Cisco, Yahoo Japan, Baidu, Ping An, and so on. And most of them are from China and the US, and also we have seen many use cases and the users came from Europe in the community. Yeah, and if you want to see more use case and scenarios with Kylin, you can go to the website of Apache Kylin to see more blogs and videos from the users. Okay, and just now we have talked about the performance and the concurrency, and here we did some benchmark. We can choose some numbers. In this benchmark, we used a standard benchmark dataset called the star schema benchmark, which includes a series of tables and a data generator to populate any size of data you want. And also it includes 12 SQL queries against these tables that we can use the tables to build a data model and to use the data generator to populate some data in any size. And also we run the 12 query those tables. And finally we can compare with SQL latency. This is the benchmark we did. So as a result, we compared the query performance between Kylin and another SQL on Hadoop engine. Actually, this is Spark SQL. In the left chart, so it's a SQL latency comparison between Kylin and Spark SQL. You can see that there are two colors of bars in this chart. The green one is Kylin, and the gray one is Spark SQL. We can see that Kylin can answer all the queries in less than maybe 1 second, but the Spark requires more seconds, maybe more than 10 seconds. Okay, and also in the right chart, it shows how the latency change with the data skill or with the data volume skill increase. As we know that Spark SQL is an MPP engine. To process more data, it will require more resources. So when the resources is limited, but the data volume got increased, so the latency will become larger because the resources is limited, but and the commutation efforts is limited, so it just requires more time. But Kylin is not. The Kylin's latency, you can see with the data scale going up, latency keeps constant. Or you can see that with maybe it's so yeah, yes, this is the result that Kylin can keep nearly constant with the data scale increase. And I will talk about more how does Kylin achieve this with the per calculation later. Okay. And the most common use case of Apache Kylin is to serve some interactive BI, such as Tableau, Power BI, and some open source BI technology like Simplifies, and also some other BIs like MicroStrategy, Cognos, and so on. With the standard SQL interface built by Kylin, and also Kylin provides the ODBC and the JDBC drivers to integrate, and also some REST API, so that the BI users can easily connect Kylin in Tableau or any other BI tools to explore and visualize the data on very large volume. So no matter how many rows of data set is under there, the interaction it will be very smooth. For example, here is a video with Tableau. There are more than 60 billion rows in the data set, but the exploration in Tableau is extremely fast in that mode. You can see that every time you switch some condition or some filters, Tableau will send the SQL queries to Kylin, execute that and get the results, and finally to display the chart here. So, it's interactive, refreshed with condition change, and also with Excel. So Excel should be the most popular data analysis tool, I think, around the world. And now with Kylin, the 60 billion rows in pivot table is doable. You can see that each dimensions and the measures can be directly synced from the cube, or you can see a semantic layer model in Kylin and shoot in Excel, which means you just load the hype tables into Kylin and to define the dimensions and measures, and finally you can use you can drag and drop the with the dimensions and measures in Excel to do the pivot analysis. This chart, okay, yeah, this chart can be refreshed here. Yeah, you can see that if you drag and drop it's refreshed very quickly. So so before this, maybe if you import billions of rows to Excel and analysis to analyze, Excel will definitely crash. So with the live connection with Kylin, the business users won't take care of the data volume in the underlaying. They can just to drag and drop, like with the most familiar way they use. Okay, so here let's look at about the part of how. So how does Kylin start the queries? Let's go deep into the basic idea of the per calculation. Firstly, Kylin will use a component called Apache Kylin to pass the SQL and build the logic plan like this. This tree structure is right, which is you can see that there is an example SQL here. There are some there are two tables to join together. The fact table is a line item and joined with another table called order. And finally, you have a date filter, and also you have some two dimensions to group by, and two columns to do the sum aggregate. and finally you will do the order by. So in the logic plan, right, it is consists of the several nodes like the table scan to the raw tables and the drawing and the filter and the aggregation and so on. This is the most usually way used by almost all of the database engines. So it's so yes, this plan is the most common plan used by every database. So with this plan, the time complexity for the process is O(n), because each row in the original tables must be scanned. So so no matter how many rows exist in the original tables, so all of them will be scanned in the query runtime. Okay, so this is original plan, but Kylin will revise this plan to leverage the pre-calculated result. We call that a Q. In fact, Kylin will compute all the aggregation results for the different combinations of dimensions and saves the result to the Q. In that example, we will see the total sum of the GMV with the group by of the time of the go back with these two group by the return flag and order status. So with the pre-calculation, we will pre-calculate the aggregation of the sum of the quantity and the price before we do the query runtime. So with the query count, it will just raise the aggregation result we have pre-calculated and stored before. So so with this revised logic, the type complexity will become O(1), because the number of the rows in the cube is decided by the cardinality of the dimensions rather than the size of the transactions. So because of the number of the order status and the number of the return flag is fixed. So the rows of the aggregated results should be also fixed. So we can see that with the fixed row of the time capacity should be O(1) in zero. Okay. And let's look at the technical architecture of Kylin to see how does Kylin do the pre-calculation and finally support the queries. Let's start from the left bottom side. The Kylin will extract the source data from Hive and Kafka. Because Hive is the most common data warehouse standard on Hadoop, and also I think maybe in today, maybe on Cloud there are most the data catalog is compatible with the Hive catalog. Yeah, and also Kafka is the very popular streaming protocol. So after the data extracted from Hive or Kafka, so the history data or the streaming data will be ingested to Kylin, and Kylin will execute a series of the MapReduce job or the Spark jobs to run the pre-calculation. Which means Kylin will submit some Hadoop jobs to read the data from Hive or Kafka and do the pre-calculations with Hadoop or Spark, and finally generate the pre-calculated results, and then save those pre-calculation results to HBase. Yeah, and as the query time, when the query sent from the application to Kylin, the Kylin will translate this query logic to a series of scan and filters to HBase and get the pre-calculation result and finish the query. Besides this, and also, yeah, the latest version of Kylin is working on some cloud native features to run all this stuff on a cloud platform. It can be used to store cubes on AWS 3 or some other object. So with this architecture, so we can use the space for time to start the queries, which means in the night, at night, there won't be any BI users or some analysts to do the analytics workload. We can use Kylin to run the calculation to save all of the results to HBase, and then in tomorrow we have several BI users will come. So when they use the BI tools to send the SQLs will get the results directly from HBase. They won't touch the original tables when in the runtime. So the performance can be ensured, and also the concurrency can be ensured, because the workload is very lightweight in the runtime. So just maybe some single server of Kylin can solve a very large of concurrent users. This is on the technical part. Okay, and also we have a use case right now, and this use case is from Yahoo Japan. Yahoo Japan is the most popular website in Japan, and this scenario is used for to support the online shopping reporting system, and they use Kylin the statistics for the store owners, based on all the transactions and the user behaviors data ingested to Kylin. Kylin can provide the high performance to calculate the impression, the clicks, and sales. Before Kylin, they used some other SQL Hadoop technologies, such as maybe Impala, in order to lower the latency. They choose Kylin to get the performance and the analysis experience is improved. So besides this, they also simplifies the whole system architecture. In the right bottom chart, you can see because they have 2 data centers in 2 countries. The situation is they have their data stored in the US, as the users, maybe most of them are BI users in Japan. So every time the BI users want to get some data, they have to go across the whole Pacific Ocean to access the data service in the US, and also the efficiency is got very slow, and also the compliance regulations rules with maybe the raw data cannot be exported from country to countries. Yeah, but with Kylin, they can build the cube in US, and finally to copy the cube to Japan, because the cube is aggregate and removed the privacy information, and that is just you can say the cube is the package of all of the aggregation results or some analysis results, so that it can be used. It can be used to pass through some compliance issues, and also the query performance can be ensured, because the queries the cube is copied to Japan. All of the BI users in Japan can use the Kylin to do the BI dashboard, BI analytics with the most nearest data service. So yeah, this is the story used by. Okay, and if you want to get more use case with Apache Kylin, you can see the blogs in Apache Kylin's website. Okay, Okay, so now let's move on to the second part to talk about the how to simplify the machine learning on big data. Usually, the data scientists do machine learning in the process like this. Firstly, the business users, they submit the requirements to data scientists, and then the data scientists ask the data engineers to provide the data, where the data engineers will write some ETL script in Python or Scala to finish the job. It may take some long time. Later, the data scientists, they want more data, or they want to modify some logic. But and then the data engineers have to modify the whole script and run the whole process again, right? So the whole process is very time-consuming and slows down the response to the business needs. And also the significant manpower is involved in the whole process, which is very inefficient and high cost. So if you have more business users and data scientists to serve, then how about the process? Maybe you want more engineers, even with data size reached to PB skill. Maybe you want more servers to this. Okay. And also, except for this, the challenges are more about the machine learning on PB scale of data size. For example, you have hundreds of concurrent data scientist users, and have to waste the engineers to deliver the development work one by one, and also more high cardinality dimensions will be exist in the data site. Maybe are you still expecting all this data in a CSV file, like the usual way? Okay. Then how about the billions of rows in a CSV file, right? And you may have some siloed data in the different data sources, maybe in the RDBMS or some object storage or Hadoop. Yes. Okay. So are you still expecting the data engineers to write the ETL to prepare the data to just combine all of the siloed data together for you? How to ensure the whole efficiency, right? And also consider to combine the batch and the streaming together. Can you get the benefits from the real-time data actually? So I think all of the answers you didn't know, right? So let me how Kylin to solve those challenges. So with Kylin, you can build unified data as a service platform for machine learning. So firstly, you can land the source data into your data lake, say maybe Hive or Kafka or some other RDBMS database, and then load this data into Kylin to build the cubes. And then the cube will become a unified data multi-layer or semantic layer. Then anybody can write the SQLs to get the data set from that. And the query performance can be ensured the precalculations, the concurrency can be ensured. Okay, so with the data set from Kylin, and also you can use any machine learning algorithm or libraries you like, such as TensorFlow, to build any intelligent applications. Because of the cube, the data scientists won't take care of how many tables, column exist in the data source. They just self-serving talk with the cubes, because the cube will provide all of the dimensions, measures to the users. They just talk with the cubes and write SQL to read the data from the cubes. So now let's go back to the challenges. Maybe you have more than 100 of concurrent users, right? So Kylin can support very high concurrency and easy to scale. So each user can self-serving get the data from the unified data service and they won't rely on the data engineers to do some ad hoc ETL codings. Yes. And also for the high cardinality dimensions, Kylin is optimized for the coverage scenarios with ultra high cardinality dimensions on the filtering, grouping, and also count distinct aggregations. So you can get the wanted result at any aggregation levels with any dimension combinations. So, and also for the side of the data, so too many data source, batch and streaming, right? So Kylin is easy to connect with any other data sources to build the queue and set up the unified data map layer with the Lambda architecture. And also that include Kafka. So Kylin can provide the real-time latency to query the data from Kafka topics. Yeah. And the Kylin is very easy to integrate with Python. So the community has released a Python tool called Kylin PY, which provides the implementation of SQL Alchemy to send the SQL queries to Kylin with Python scripts. So in this script, in this screenshot, there is some lines of code you can see. You just need to give the URL of Kylin server and the username password to build the connection, and then you can just write a SQL to generate a pandas data frame, and also and then and just I think every data scientist should be very familiar with the data frame, right? Yeah, it's very easy to use from here. So to better leverage the high performance of Kylin, in fact, you can write any SQL in each aggregation level to get the data to get the data frame, and you can do any exploration, the visualization, active in seconds. So no matter you modify the SQL, you can add some dimensions, you can add some measures to get the data size. Every time you modify the SQL, you can just quickly get the result and do the visualization to finish the data exploration. Okay, so, and the data size in the underlying may be very large. So from this screenshot, you can see the chart built with Kylin and Python. In fact, this whole code and the scenario there is a blog in the Kylin website. You can also more details and get the code on the website. Okay. Okay, and we have prepared a demo video to tell the story about time series prediction with machine learning. The demo is to simplify the machine learning part. We used the AutoML technology to simplify the machine learning part. So the AutoML is called automated machine learning, which can be used to automatically select the algorithm and tune the parameters according to the input data, and finally generate a well-trained model, so with which the users won't have much knowledge about the machine learning. So they can achieve the very good result with machine learning. So with the AutoML, we can just simplify the machine learning part, because so that we can be more focused on the Kylin part to get the data, and also with AutoML we can just ask it to populate a well-trained model for us to finish the demo. Okay. So so this demo will tell how to use Kylin and AutoML to predict the sales GMV. The data set is is based on a dataset called Console, provided by Microsoft on the public website. It's in PB scale, and we provision all of this on the Microsoft Azure cloud platform, and then use the auto ML service on Azure to run the machine learning. Okay, so now let's start. Okay, so this demo is to start with a time series prediction, because in the retail industry, the sales activity is time series data. Okay. So here is the redistribution version of Kyligence. If you got stop. Okay. So we load the tables into Kylin and connect the tables in the setup of the aggregation. Okay. Here we just to load the tables. We just all of the tables in Hive will be displayed here, and we can just select them. And after we import the table, we can add a data model to build the queue. So here we just drag and drop to build the ER graph, to build the tables connections, and set up the aggregations and the index rules to build the queue and build the pre-calculation. Yeah. Okay. And then after we build the cube, we can start analysis with Python. So we can build a connection and read the and write the SQL to get the input data, and then use auto ML to train the model to forecast total GMV in the next months. Okay. Okay, so here is the result. We can see that the trend is going down in future is with the orange point, which means that the business of the store is going bad in the next months. So they must make the decisions to win back. Okay. So okay. Okay. So we can modify the SQL to add some filter to a specific product, maybe into the SQL to forecast the GMV for a single product. Since the query performance is very fast, we can easily traverse on the most products to predict the future GMV for some single product. And finally, we can find that the product, one of the products called product A, will go up in next months. So then the manager of the store can make some marketing plan based on the results. So because the product A is a better choice. Okay. So yeah, as a conclusion, in order to get the data insight and make the decisions, the data scientists, they can just self-serving write the SQLs from Kylin to get the data and run the predict. So they can do the very flexible predictions easily. So even on very large scale of data science, they won't rely on the data engineers to extract the data and provide them to provide the data. So the manager from the business side can quickly make the decisions based on the latest data insights provided by the data scientists. So that is what we can what say and or what they can benefit with the solution we talked about today. That is to simplify the machine learning on the big data with Apache Kylin, with the data service with or with the high performance data service provided by Apache Kylin. Okay. Till now, we have finished the presentation today. So maybe let's start the Q&A session. So any questions?
Looks like we got quite a few questions here, actually. So
Okay.
good job, Don. Yeah, this is great.
Thank you.
Yeah, I'll start from the top and then read down. That's probably the easiest thing to do. Fitz asks, does Kylin rely on the Hive metastore like Impala or Spark SQL do?
Okay, this is a very good question. In fact, not. In fact, the answer is no, because on Kylin, in fact, we need. I can answer that. So on the query side, the Kylin does not rely on the Hive metastore, because Kylin have its metastore itself. So we have a table sync process for the users, which means the users they may have lots of the tables in Hive, but they just want to use Kylin to establish a part of those. They just sync those tables to Kylin to do the accelerate, so that in the query side, the users can only see the part of the established tables. So the answer is no. But on the build side, Kylin Kylin reads the tables metadata from Hive metastore. So from this side, we can see that Kylin is relying on the Hive metastore. Yeah, it decides different scenarios. Okay, does that make sense?
Does that answer your question, Fitz? Yep, thanks. Cool. All right. Samantha asks, what's the difference between Apache Kylin and other SQL on Hadoop technology?
Okay. And in fact, there are 2 points of difference in Apache Kylin. The first one is Kylin uses the pre-calculation to accelerate the queries, so which will bring the win side on the large data side. And the second one is a semantic layer, because Kylin is not only a SQL engine, but also a semantic layer where you can define the data model, dimension, and measures, and finally you can use the API to use the metadata. I think for the most SQL Hadoop technology, they won't provide some semantic layer capability.
That's helpful. I mean, when you profile Kylin against other, how would it compare against Presto, for example, in terms of performance?
You mean what performance? You mean the query performance?
Yeah, maybe using latency as an example. Yeah.
In fact, I have a benchmark chart here where we have compared the SQL latency between the different technologies. In fact, different technology has its key competency in some scenarios. Kylin can do better on the OLAP and aggregation scenarios. So maybe other SQL Hadoop, they can do better on some maybe ad hoc queries or some search scenarios. So yeah, you can see that for different scenarios, you can choose different technologies. Yeah.
Right, makes sense. Cool. John asks, how quickly can cubes be built?
Okay. In fact, that depends. That depends on how large the cluster you have on the Spark. Sorry, on the Hadoop, and also how much data you want to load. So as a result, in a short answer, maybe the build process can have maybe the 10 minutes can vary from 10 minutes maybe to several to half an hour, maybe to 1 hour. It depends because but usually you can see that there are a lot of ETL process on the data pipeline. you can see that maybe the queue building phase is just the downstream of your ETL pipeline. So and all of the pipeline happens on the at night. That okay. So at that time, the users won't take care of more about the latency. So most of the users they can accept the build latency with tens of minutes. Yeah.
Okay, cool. This fits this question as well. Samantha asks, how would Apache Kylin integrate with an existing data pipeline?
Yeah, very good question. In fact, Kylin stands after the ETL processor, just like I said just now. That is, when you finish the ETL and get the have table ready, then you can call the REST API of Kylin to trigger the queue building job in Kylin. So, because Kylin provides a series of REST API to integrate with existing pipeline and also the schedule system, you can just trigger that to call the API.
Got it. That's cool. And then I guess a related question, in addition to Kafka, what kind of streaming inputs does Kylin accept? Okay,
very good question. Currently, Kylin can only support the Kafka out of box. Yeah, because we have already implemented the Kafka data source connector. But just like I said, Kylin is a Lambda architecture, or you can see it's a pluggable architecture. Everyone can contribute to write some implementation with any other data source. If you want to ingest with more real-time source, yeah, you can just to write some Java code. You can implement that because Kylin is open source software. Everyone can help to contribute. Recently, we have some contributors to have contribute a lot of features such as the data source with Elasticsearch. We can help to raise the data from ES. Also, they can to build the queue with Flink. So yeah, like we have seen a lot of contribution from the community. Yeah.
Awesome. Anyone else have questions? Awesome. Well, this has been a really cool chat. So thanks, Don. I actually not known much about Kylin before, and I'm very impressed. This is pretty remarkable technology. Is Kylin's development done in like globally, or is it mainly China or US? Or walk me through that real quick.
Yeah, in fact, it's globally. It's globally. Yeah, we have a lot of contributors and committers in US, in Europe, and also in Japan. Okay. Yeah. Cool. And as far as Kyligence goes, then is that US or China based, or what's the story there? Yeah, you mean for Kyligence? Okay. Yeah. So, yeah, Kyligence is dual headquarters. We have one of the headquarters in Shanghai, and also one in the Bay Area. Okay, cool. Yeah, and we have some we have offices in most of the cities like Seattle, like New York. Yeah. Oh, it's a pretty big presence. Awesome. Cool. So I guess if people wanted to find out more about Kyligence, would they just go to kyligence.com, or what's or contribute to the project? Maybe tell people how they could learn more about both Kyligence and Kylin. Yeah. We should have. I have some. We have some website URL in my slides here. You can see we have LinkedIn, we have Twitter for Kyligence and Apache Kylin. And also, we recommend you to subscribe the mailing list of Apache Kylin to learn more about Apache Kylin's, maybe some discussions and use cases in the mailing list. Thanks. Awesome. Cool.
Well, thanks everybody.